Okay guys, so welcome ulit sa ating YouTube channel. Ito na yung lesson 23 sa ating advanced calculus. Ito na yung probably huli sa mga properties na pwede kong ibato sa ating function with regards sa ating sequence. So kumbaga with related sa ating sequence. Okay. So let's have proposition 3 kasi nga tuloy-tuloy last time nag-proposition 2 tayo. So let's have proposition 3, 3 sorry. Let I be an interval and let f be a function mapping from the interval I going to real number be strictly monotonic, then f inverse of I is equal to f of I going to real number is continuous. So again dito example na lang, nagbigay na lang ako na example na kung saan makikita natin na pareha silang continuous as pareha sila ng domain. Okay, so gawin ko is yun example. Okay, so example, let's consider this piecewise function defined by x whenever x is an element of 0, 2. Next is 1/2 x plus 3 whenever x is an element ng open sa 2, 4 close. Okay, then next is i-graph natin yan. So, paano ba natin i-graph yan? So, ganito mag-graph ng piecewise function na. So, I think aware naman na kayo dito siguro. So, pasensya na kayo sinisipon din si sir. So, I think ito yun. Suppose ito yung 1, 2, 3, 4, then 5. Then, let's say dito naman sa kabila. We have 1, 2, 3, and 4. Okay. So, paano tayo mag-graph dyan? So, kung napansin mo, interval yung given. Kailangan makita natin siya strictly monotonic, meaning increasing siya or decreasing. So, dapat makita natin. Sige nun. So, una natin x element ng 0, 2. So, start na tayo for 0. When x is 0, f of x, f of 0 is 0. So, dito yon. So, kung napansin mo, close. So, close siya dito dapat. So again kinuha ko yung 0, kinuha ko yung f of 0. Okay, so ginamit ko when x is 0, that is 0 lang. Next, kunin ko yung maximum niya when x is 2. So since pasok naman siya doon, so when x is 2, f of 2 is 2 kasi papasok siya dito. So meaning f of 2 is 2. So dito yan. So somewhere dito. Okay, so duduktong ko yung dalawang yan kasi sila ay magkasama sa domain 1. And yung domain na 0, 2. Okay, next is whenever x is open sa 2, for example, kinuha ko si 2. So, whenever x is 2, substitute doon, 1/2 times 2. So, again kinuha ko yung 2, pero open. 1/2 times 2 is 1 plus 3, that is 4. Tama? 1/2 plus 2, that is 4, no? 4. So, open sa 4. So, 2, 4. So, ang mangyayari, this is 2, then 4. Dito yan. Pero open. Kasi open sa 2. Ginamit ko yung open na 2. Kaya open sa 4. Next is, whenever x is 4, so close, pasok yan. So, whenever 4 is x, whenever x is 4, that is 1/2 times 4 is 2 plus 3, that's 5. So, that is 4, 5, that's close. I think dito. Okay, so i-graph natin yan. Ito yung itsura. So, kung naman mo strictly monotonic siya, increasing siya. So, yan yung graph ng function. So, again, paano ginawa sir? Kinuha ko yung dulo-dulo na interval. Yung lower bound, tas yung upper bound. Yung pinakamaliit na value, tas yung maximum value. Kada interval. Tapos, ganun yung graph. Tapos, kung open butas. Okay? Kung close siya, close din yung ibubutas mo. Or shaded part. Yung ipabubutas mo. Ngayon, ano ba ibig sabihin ni sir dyan? Ngayon, try natin kunin yung inverse nito. So, saan siya na? Sinisipon si sir. Try natin kunin yung inverse. So, paano natin kunin yung inverse? Una, ito yung unang domain, no? So, yung unang function is f of x is equal to x. Okay, so, whenever f of x is equal to x, ano yung inverse niya? So, una, f of x is equal to x. So, yung inverse na, gagawin natin y yan. Y is equal to x, pagpapalitin lang. So, therefore, f inverse of x lang natin is just x. Kasi wala mangyayari. Next, ito, pagpalit natin. Kunin natin yung pangalawa. Let's say, sa si g. Let's say si g of x is equal to 1/2 x plus 3. Gagawin natin itong y is equal to 1/2 x plus 3, tas interchange, this is x is equal to 1 half y plus 3 multiply by 2, this is 2x is equal to y plus 6. So therefore y is just equal to 2x minus 6, or simply g inverse of x is equal to 2x minus 6. Okay, then rewrite natin yung kanyang inverse dito sa kabila. So since piecewise siya, piecewise function din yung pagkakalagay ng inverse. So f inverse of x is equal to, una, x pa rin. Okay, so ano naman yung magiging range niya? Ang magiging range niya is similar, ganun pa rin. Kasi ayun lang din kakalabasan eh. So this is x element ng 0, 2. Pangalawa is 2x minus 6. So ano yung mga element ng 2x minus 6? So kung napapansin nyo, element ng 2x minus 6 is ito. Kasi ito kanina, ito yung domain. Ito yung domain kanina nito. Ito yung range, sorry. Ito yung range, yung possible range values ng ating f of x equal to x. So kaya yung nakuha natin na range na. So alam nyo natin na pag inverse, yung range na yung nagiging domain ng inverse. So dito, ano naman dito? Ano yung magiging domain ng ating, ano yung magiging range domain ng ating 2x minus 6? So sir, hindi pa pwedeng ito. So, hindi ba pwede na si 4 open sa 4 as close sa 5? So, this is x element sa open sa 4 tapos close sa 5. Kasi ando dun siya. Somewhere sa value na yun. So, again, kinuha ko yung function dito. Dito ako nagbase kasi yun yung mga range kanina. Kaya ako ginap. Okay, so, ano ba pinopoint out ni sir? Kung napansin nyo, increasing siya, yung f inverse na is yung f of I. Kung napansin mo, f of I pa rin yan. Tapos, ano ba ang pinupoint on this sir? Ang gusto ko ipakita sa inyo, ano ba yung magiging graph nito by the way? Okay, so try natin i-graph. By the way. So pag ginraph natin yan, so let's say, ito isang graph niya. So ibang kulay. So similar number pa rin naman. So bilang na lang tayo dito, 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. So una, for x is equal to 0, that is 0. Dito pa rin. Okay, for x is equal to 2, that is 2 pa rin. So let's say dito yan. So hindi dito pa rin yan. So papansin mo, close pa rin dyan. Okay, next. For x is equal to 4, that is 2 times 4, 8 minus 2 is 2. So that is 4, 2. Okay, kung napapansin, 4, 2 dito mapupunta. So open dito. Tapos for x is equal to 5, so this 2 times 5 is 10 minus 4 is 4. So 5, 4. So dito yan. So this is close naman dito. Okay, so kung napansin mo, almost the same pa rin sila lang. Hindi naman almost the same, pero increasing pa rin. Kasi ang point out nito is let f be an interval, then let f be a mapping from I to real number is strictly monotonic. Then f inverse of I is equal to f of I mapping to real number is also continuous. Since continuous tayo dito kanina, hindi lang siya continuous dun sa 2. Okay, actually continuous sa 2 eh. Continuous sa 2 kasi pupunta lang siya dito. Okay, so dito naman is continuous pa rin siya. Continuous pa rin siya. Pero syempre hindi nakasama yung ibang real number part dito. Okay, so sulat lang natin ano yung f of I. Sulat ko f of I, no. F of I based sa nagawa natin is yung interval. So sorry, this is double tugtog. Interval na 0, 2. Open tayo dyan. So this is 0, 2. Ayun yung domain. Union 4, 5. Okay, 4, 5 mapping to real number. So ayun yung mga domain na ipapalit natin. Ngayon, yung f inverse natin yan, okay, is just by definition. Ano sabi ng definition? By definition, f of I inverse is just f of I. Okay, what is f of I? Yung mga range ng f of I. Napansin nyo yung range ng f of I is just ito ulit. Okay, so that is simply 0, 2 union 4, 5. Okay, going to real number. So sorry, ito i-close. Okay, so ayan yung sinasabi ng proposition 3 na yan. So strictly increasing pa rin sila, then therefore continuous pa rin naman yung f inverse of I natin. Okay, so let's have another corollary. So corollary number 8. So kasi theorem number 7 tayo. So for corollary number 8, so let I be an interval and f be a mapping from I to a real number. Okay, and be strictly monotonic, so meaning increasing or decreasing ulit siya. So such that f of I is an interval, then f is 1 to 1 and continuous on I. So I think i-graph ko na lang to. Paano ko bang papakita na graph to? So dapat strictly monotonic. So I think i-relate ko na lang sa nangyari dito. Okay, so gagawa ko dito ng malaking graph niya. So i-relate ko na lang dun sa nangyari. Let's say ito yung A. Let's say ito yung B. So una nangyari is just, kunyari somewhere dito is shaded siya. Pagdating somewhere dito is open. Okay, so nangyari, nagkaroon ng ganyan. Ngayon, ibig sabihin niyan, dito may counterpart siya. So yung katapat niya dito, open dito, close dito. Okay, tapos ito yung interval somewhere. Okay, so yun yung ibig sabihin kasi open doon, yun yung ibig sabihin yan. Next, what if dalawang close naman? Kunyari humugot ako dito. Kunyari dito, somewhere dito, close. Tapos somewhere close. So, graph natin yan. So, may katapat yan syempre dito. Pero close na yun. Okay, so yun yung ini-imply nung ganyan. So, f of I is an interval and continuous on I. So, ayun siya. Yung f of I, andi dito yan. So, interval sila. Tapos, 1 to 1 pa rin yan and continuous on I. Yan yung mga ibig sabihin nila. Okay? So, paano ko pala papakita? Again, interval pa lang pala pinapakita ko, no? So, napakita ko pa lang na si f of I is interval. So, ito yun, no? F of I dito. So, may f of I dito. Kunyari, f of I dito naman is f of I sub 2. Okay, kasi nga dalawa yung interval na ginamit. Okay, so, paano kaya papakita na siya ay continuous? So I think ganito, kung naalala nyo dati, paano ba natin nire-represent yung continuous? Balik ta rin ko na. So for example, ito yung ating graph. So let's say ito yung A, let's say ito yung ating B, tapos ito yung I somewhere. Okay, so ito yung f of A, tapos ito yung f of B. Okay, so let's say may function dyan somewhere. Okay, then itatapat ko lang to. So ito, tapat-tapat dyan. Yan, then tapat ko do sa B. Okay, then sa may mag-exist dito na K. Okay, such that yung K na yan isakto dun sa I. Okay, so whenever siya si f of I. So, continue siya dun. So, kumbaga may epsilon delta neighborhood dito. Somewhere dyan. Yun ang may ibig sabihin niya. So, kumbaga, continuous ako kasi may epsilon delta neighborhood na nag-exist dito. Okay, so, ganyan naman yung corollary number 8. Yung next pin ni corollary number 8. Okay, next is proposition 4. So, ito medyo kakaiba kasi kailangan i-prove or sabi na let I be an interval. Let I be an interval. So, tanggalin natin itong ND. So, let I be an interval and let F be a mapping from I to real number such be 1 to 1 and continuous. So, again, yung F is interval yung I, tapos nangyari 1 to 1 yung function natin as continuous. Then the inverse, F inverse mapping from f of I going to real number is continuous, and in fact is f is strictly monotonic on I and f of I is an interval. So ayun yung mga kailangan nating ipakita. Okay, so I think pwede ko siyang gawin ng ganito. So kung naaalala nyo ano ba si IBT tapos si proposition 3. Okay, si proposition 3 ang sinasabi niya is strictly monotonic siya. So whenever I is an interval, then f of I mapping to real number be strictly monotonic, then f of inverse of I is f of I going to real number is continuous. So ayun yung mga gawin natin. So in view of ito yung gagawin natin proof. So hoping na gumana yung naiisip na sir. So in view of proposition 3 and IBT, so intermediate value theorem, yan yung IBT. We only need to show that f is parang we need to show that f is strictly monotonic. So yung word na strictly monotonic. Okay, since in view of proposition 3 and IBT, ang kailangan natin gawin is kailangan 1 to 1 ako at the same time continuous ako. Okay, so kumbaga F is 1 to 1 and has the IBP strictly monotonic. Kumbaga ang gagawin ko lang, so we need to show, or our goal, ito na lang, our goal is F is 1 to 1 and has the IBP. Okay, so intermediate value theorem or IBT has the IBT or intermediate value IBP, intermediate value property. So theorem pa rin yun. So kasi pala na-prove ko na so kaya property ng tawag ko. So is strictly monotonic. So ayun yung dapat i-prove natin. So, dapat mapakita natin na si F is 1 to 1 at the same time yung IBP niya is strictly monotonic. Kumbaga para strictly monotonic na F of A is less than C less than F of B, or F of A is greater than C greater than F of B. Parang ganun yung mangyayari dapat kaya strictly. So una dapat 1 to 1 siya, tapos pangalawa tapos dapat yun. Pero syempre gaya ng sabi ko sa inyo, another thing, mahirap siya. Kumbaga, sir, paano yun? Mag-i-start ako from nothing, wala akong gagawin, wala akong, kumbaga kahit anong assumption, alam ko lang may function ako, so wala akong nalit. So, ganun yung kasi mga nangyari. Kung imaginein mo, no? Sir, nag-i-start lang ako sa function. Ang alam ko lang sa function is ganito. Meron siyang, siya ay 1 to 1, tapos continuous. So, sir, interval siya. Hindi ko pa naman alam kung anong klaseng interval siya. Ayun kasi yung mga view na pwede mong makita eh. Okay, so ngayon, sabi ko nga sa inyo, kung tingin mo, hindi mo na siya maayos, or hindi mo na makita sa proving na, or hindi mo makita, ma-imagine yung proving na gagawin mo pag ganun, yung direct proof, what if pagpunta ka by contradiction? Okay, so suppose not. Okay, so lagay ko, suppose not. Suppose not, so that is there exists x sub 1, x sub 2, y sub 1, and y sub 2 element of I such that ito yung mga gagawin ko. So suppose hindi siya increasing or decreasing, so graph ko lang dito, pakita ko lang, assuming ito yung ating graph. Let's say nandito si x sub 1, dito si x sub 2, nandito si y sub 1, tapos nandito si y sub 2. So suppose na hindi siya decreasing, so nangyari ganito. Okay, ganyan yung itsura ng function. So, hindi siya strictly monotonic. Okay, so decreasing tapos biglang increasing. Ganyan nangyari. Okay, so suppose ganyan nangyari. So, such that, ano napansin mo? Yung ginawa ni sir, ang napansin ko, yung f of x sub 1 is greater than f of x sub 2. So, note na sa x sub 1, such that x sub 1 is less than x sub 2, but, x sub 1 is less than x sub 2, but sa f of x sub 1, f of x sub 1 is greater than or equal sa f of x sub 2. Okay, and kung napansin mo doon sa sunod, y sub 1 is less than y sub 2, y sub 1 is less than y sub 2, but f of y sub 1 is less than f of y sub 2. Okay, ngayon suppose natin, so maglilet ako dyan ng minimum. So suppose somewhere andyan dyan si A. So somewhere andi dito, some part of that. So kunyari, some part na itong dalawang to, nandyan si A. So hindi ko alam kung nasan. Somewhere, some part dito naman dyan si B. So kumbaga may minimum dyan. Okay, so let natin. So mag-let lang ulit ako. Let natin na A be the minimum between x sub 1 and y sub 1. Okay, kasi nga somewhere sa kanilang dalawa. Okay, somewhere sa kanilang dalawa yung minimum. Kasi nga si x sub 1 saka si y sub 1 parehas less than dun sa x sub 2 saka y sub 2 respectively. Next si B, be the maximum between naman dun sa dalawa, sa x sub 2 and y sub 2. So ano ba kiniklaim ni sir? Ang ginawa ko, since may nag-exist na ganyan, ano ba clear na nakikita ko? Clear na nakikita ko yung A is strictly less than dun sa B. So clearly, lagay ko na lang no, clearly A is less than B. Ngayon, since A is less than B, A naman yung pag-uusapan natin. Okay, so meron tayong two cases. Lagay ko lang dito. So we have 2 cases. Okay, so for case 1, okay, una, f of A is less than or equal sa f of B. Ayun yung una ko. Kasi nga, gusto kong kunin yung f of A. Somewhere hindi ko kasi alam kung nasan si A. Somewhere hindi ko alam kung nasan si B. Pero alam ko si A is minimum. Alam ko si B is maximum. Okay? Ngayon, suppose na yung f of A, f of B, f of A is less than f of B. So, sir, possible? Yes. For example, dito sa f of A, tapos nandito sa f of B, nasa taas. Mga ganun yung pointing niyan. Okay, kasi arbitrary siya, nasaan eh. So, ngayon, ano ba kailangan natin pakita? So, kung ganyan yung gusto natin mangyari, so, we need to show na si f of x sub 1 is less than sa f of b. Kasi hindi, si f of x sub 1 yung pinakamaliit eh. Okay? Kasi hindi natin alam kung sino siya. So, we need to show, so, we must have f of x sub 1 less than or equal sa f of b. Okay, so, since totoo yun, ano ba mangyayari dyan? Tama naman, no? Si f of x sub 1, somewhere doon, dapat less than sa f of b, somewhere doon. So, kunyari, baka ibig sabihin niyan, yung f of b nandun sa taas, pinakatuktok, kumbaga mas mataas pa siya doon. Ayun yung mga kailangan natin. Less than or equal, so pwede rin mag-equal ng distansya. So, ano ba yung possible natin na gagawin dyan? Kung ganyan nangyari, by IBT, or some... So, again kailangan ganyan yung makita natin. So, next. So, we must have that f of x sub 1 is less than f of b. Again, imagine natin, nasaan siya. So, si f of x sub 1, somewhere nandito, ang taas na niya. Tapos, ibig sabihin, si f of b, mas mataas pa pala. Kumbaga, yung function continuous ba dun pataas? Somewhere baka nandito. Ganun nangyari, ganun yung sinasabi na kaya mas mataas. Kaya kiniklaim niya mas mataas. Eh, what if hindi? Okay, so, what if not? So, ito yung tanong, what if not? So, what if hindi totoo yun? Yung f of x sub 1 is less than f of b. Kung ganun yung nangyari, ibig sabihin, kung si f of x sub 1 is not less than to f of x to f of b, sorry, ang mangyari, yung f of x sub 1 is baka mas malaki kay f of b. Okay, ngayon, ang sabi ng ating assumption, si f of b is greater than or equal sa f of a. So, this is greater than equal sa f of a. Okay, ngayon, by IBT, ang sabi ko, since increasing na siya, kung nabansin nyo, no, f of x sub 1, f of b, tapos f of a, somewhere f of a, kumbaga mas mataas, no, pag ganun. Or, sa f of a, sorry, sa f of a yung maliit, tapos f of b, kumbaga, nangyari is, andito ako, sa point na to, tapos bigla nandito, tapos nandito, kumbaga pag ganun nangyari sa function, pero increasing. Okay, so, since ganyan nangyari, by IBP, or intermediate value property, or intermediate value theorem, so by IBT, so pwede kong gamitin yun, kasi nga increasing na siya. So, by IBT, there exists C sub 1, element nung, nung A, X sub 1, so somewhere dito. Okay, kasi hindi ko alam kung somewhere nasan siya dyan eh. Hindi ko nga alam kung nasan si A. So, let's say, siya yung element ng A, X sub 1. Okay, so, ayun din, another way din para masabi ko nasan si A. Si A, possible baka nandito sa dulo. Possible baka nandito si B. Ayun yung mga pwede kong sabi. Kasi nga, minimum siya between X sub 1 and Y sub 1. Tapos maximum siya between X sub 2 and Y sub 2. So, again nga, hinuhulaan ko kasi kung nasan siya. So, ngayon, assumption ko lang, what if yung A, X sub 1, so, somewhere nandito dyan. Meron daw C sub 1 doon nag-exist such that si f of z sub 1 is equal to f of b. Kumbaga, f of c sub 1, somewhere dyan, sakto siya sa f of b. Nakuha ko si f of b. Okay, so note, ano mangyari? Note that c sub 1 is less than x sub 1 is less than x sub 2 and less than b, which is a contradiction. Sir, bakit mo nasabing contradiction? Nasabi ko na meron daw C sub 1 somewhere ando doon. Okay, may C sub 1 daw between dito na kung saan ma-attain ko si f of b and dito si b. Okay, imagine mo andito si b. So, ibig sabihin parang bumalik yung function pag ganun. Okay, so which mean hindi siya contradiction. Assumption pa lang natin 1 to 1 siya. Okay, ito, ibig sabihin ito, hindi siya 1 to 1 kasi dalawa yung bumalik. Okay, so ibig sabihin, so f is 1 to 1. Yan yung una. Okay, so note natin yung pangalawa. Yung pangalawa naman, no, if f of x sub 1, so from naman balik tayo, no, f of x sub 1, di ba dito f of x sub 1. So puntahan naman natin to from f of x sub 1 less than or equal sa f of b. So puntahan naman tayo, ano mangyari dyan? F of x sub 1 is less than sa f of b, kumbaga mas maliit siya doon. Baka sinasabi natin increasing, ano mangyari? Si f of x sub 1, this implies na si f of x sub 2 is less than f of x sub 1 less than f of b. Sir, bakit f of x sub 2? Sabi ng assumption, si f of x sub 1 is greater than f of x sub 2. Kaya nasabi ko yan. Okay, so since from dyan. So, nangyayari again, katulad nangyari dito, ito increasing kanina, ito decreasing. So, by IBT again. So, by IBT. So, there exists C sub 1, W1, W sub 1 naman. So, there exists W sub 1. Element naman nung X sub 2, B. So, somewhere naman na dito. Okay, such that yung F of W sub 1 is equal sa F of X sub 1. Kung baka sinakto niya. Kinuha naman na si F of X sub 1. Kanina kinuha na si F of B. Ngayon naman kinuha na si F of X sub 1. Dalawa kasi kinukumpara natin. Itong dalawa. Okay, so kanina nangyari, nakuha natin na si F of Z1 is equal to F of B. Pero si Z1 is less than sa X sub 1. So, ibig sabihin, hindi totoo yun. Contradiction. Nandito naman, kinuha natin si there exists a W sub 1 element ng X sub 2, B, such that yung F of W sub 1 is equal to F of X sub 1. Sorry, this is F of X sub 1. So, pakilagay ng sub 1 yan. Okay, then, no, ano mangyari? Now, si X sub 1 is less than X sub 2, less than equal sa W sub 1, which is another contradiction. So, kasi nangyari na naman, umulit-ulit, another graph, pag ano naman, baga babalik ako, papunta doon. Parang gano'n nangyari dyan. So, F is 1 to 1. Okay, so ano naman na strictly increasing na siya by IBT. So strictly monotonic to siya by IBT, gamit to. Strictly monotonic by IBP. Tas another, since nagkaroon ng contradiction, 1 to 1 siya, then 1 to 1. So ngayon, sa case 2, hindi ko na siya ipoprove kasi sasama ko siya sa problem set. So per case 2, ang mangyayari sa case 2 is ipoprove natin na si f of A is greater than f of B. Okay, so yan naman yung pag-isipan nyo mabuti kung paano mangyayari dyan. So again, imagination dito yung kailangan nating pagganahin. Okay? Okay, so let's have definition. So we say that f mapping from D going to real number is uniformly continuous on D if and only if for every sequence x sub n and y sub n in D with x sub n minus y sub n approaches to 0. So x sub n minus y sub n approaches to 0. We have f of x sub n minus f of y sub n approaches to 0 also. So yan yung pagiging uniformly convergent. So remark, if f is uniformly continuous on D, then it is continuous on D. So automatic, kung ikaw ay uniformly continuous on D, therefore ikaw ay continuous on D. So ano ba ibig sabihin ng uniformly? Dalawang numbers yung pinag-uusapan. Kumbaga, sa pagiging continuous, isang number lang. So kumbaga, continuous ako sa C dito, dalawa. Continuous ako sa dalawang number. Okay, sa dalawang, dari kumuha ko, let's say x sub 1 and x sub 2, continuous ako sa dalawang yun. Yun yung ibig sabihin. Kumbaga, kinukuha natin yung dalawang number. Okay, it is not necessary na dapat magkahiwalay yung kuha. Meaning magkalapit naman yung kinukuha dito sa pagiging uniformly continuous. Okay, then sundan natin ng proposition number 5. So, proposition number 5, if D is closed and bounded set, then every continuous function on D is uniformly continuous on D. Okay, so ano ba ibig sabihin natin pag dinrawing? Pag dinrawing, kasi bound eh. So, closed and bounded. So, we have this. So, let's say, ito yung A, ito yung B. So, yun yung ating closed and bounded interval. Okay, so let's say, ito yung ating function. Okay, so, yan, ito siya. So, continuous daw siya dun sa loob, no? Meaning, continuous sa part na to. Okay, so, continuous ka dun sa domain yan. Ngayon, gusto ko, kailangan natin i-prove yan. So, try natin i-prove to. So, I think, isip tayo ng way para ma-prove to. Okay, so, I think, ganyan ulit, no, mag-i-start tayo. Kung mag-i-start tayo sa pagiging close and bounded niya, ganyan na start. So, imagine mo, maglilet ka ng interval, A, B. So, gagawa ka ng way para maging uniformly continuous. So, ibig sabihin, nahuhugot ka, parang ganun. So, ngayon, pinakamadaling way siguro para ma-prove natin siya is, I think, by contradiction again. So, proof by contradiction. So, try ulit natin by contradiction. So, proof by contradiction. Okay, so, by contradiction, suppose F is not uniformly continuous on D. Uniformly continuous on D. Okay? Since hindi siya continuous on D, pero may mag-exist pa rin na sequence. Okay, then natin ganito, then there exists two sequences. So, two sequences, let's say x sub n subset ng D and y sub n naman subset ng D. Okay, such that yung x sub n minus y sub n approaches to 0, but kasi nga nag-contradiction tayo, mangyari yung f of x sub n daw, yung f of x sub n minus f of y sub n is not approaches to 0. So, yan yung pagiging contradiction niya. Kumbaga, ipinasok ko yung conclusion ng definition. So, pinasok ko yun, di ba, we have, ito yung conclusion. Ipasok ko siya, nag-negate. Ang negation niya is yung f of x sub n minus f of y sub n not approaches to 0. Okay? So, ang goal natin that makapagpakita tayo dyan ng somewhat or somewhere contradiction. So, ngayon, focus tayo. May dalawang sequence pa rin naman tayo dyan. Okay? So, start tayo una kay x sub n. Okay, so we start with x sub n. So, or again, focus, or I think consider. So, consider x sub n. Okay, ngayon, since D is bounded, so aware naman kayo, D is closed and bounded. Since D is bounded, x sub n is also bounded. Okay, then x sub n is also bounded. Ngayon, since bounded si x sub n, anong sabi ni Bolzano? Pag ikaw ay bounded na sequence, by Bolzano-Weierstrass theorem, so by BWT, okay, so x sub n has a subsequence. As a subsequence, x sub n sub k, so x sub n sub k, that converges to, let's say, C, for C element of domain. Okay, so ganyan yung mangyayari. So, ayun na pag yung x sub n natin is bounded, so therefore by BWT, meron siyang subsequence sa x sub n sub k, which is approaches to C. Okay, for C element of D. Ngayon, consider natin si y sub n. So, same index lang naman sila. So, pares lang naman sila, no? Si y sub n saka sa x sub n. So, also, meron din tayo. So, also by Bolzano, or consequently na lang, y sub n sub k approaches to C rin for C element of D. Okay, so ngayon, apply natin yung definition na to. Sabi, yung x sub n minus y sub n, so since sila ay parehas naman subsequence ng x sub n saka y sub n, pwede natin, so pwede nga to, so yung x sub n sub k minus y sub n sub k approaches to 0 pa rin naman. Okay, or sir, bakit? Kasi ito ay parang C minus C. Kumbaga, C minus C that is equal to 0. Ganun yung nangyari dyan. Kaya approaches to 0. Ngayon, i-check natin. So, it follows. Ano mangyari? It follows. So, it follows that f of x sub n, yung f of x sub n sub k minus f of y sub n sub k is approaches to f of c minus f of c. Kasi pareha silang approaches to c. Kasi ang nangyari, x sub n approaches to c, then y sub n sub k approaches to c. So therefore, yung x sub n, saka yung f of x sub n sub k, saka yung f of y sub n sub k, is parehas f of c and f of c, which is equal to 0. Which is equal to 0. Okay? So, this is a contradiction from this. So, kung napansin mo, contradiction sa dyan. So, therefore, so, conclusion, so, done ko na yan. Okay, so, any continuous function on closed interval AB is uniformly continuous. Okay? So, tandaan yan. So, basta closed interval siya, automatic uniformly continuous yan. Basta continuous siya dun sa closed interval natin. Although, lagi nga ang claim is continuous naman talaga siya lagi dun. So, depende talaga yan sa function na given. Dun sa defined na function. Okay, so now, let's have remark. So, ito example na lang bago tapusin yung video na to. So, ito na yung last property sa ating function. So, ating continuity, sorry. Ang gagawin ko is just, magbibigay lang ako example na ito. So, sabi remarks, number 1, closeness is important and necessary. So, anong klaseng example yung magsabi na closeness is important and necessary? So, suppose we have f of x sub n. Suppose meron tayong f of x is equal to 1 over x minus 1 on 1, 2. Okay, so hindi siya close kasi open siya sa 1. Okay, so pero bounded siya. Tama. So, hindi siya close kasi open sa 1. Ngayon, hanap tayo ng sequence. So, consider natin 2 sequences. So, consider yung 2 sequences. So, may 2 sequences ako. Let's say, 2 sequences. Let's say, si 1 plus 1 over n and 1 plus 1 over n plus 1. Okay, so pansinin nyo ano yung x sub n minus y sub n? Yung x sub n minus y sub n is just 1 plus 1 over n minus 1 plus 1 over n plus 1, which is equal sa 1 over n minus 1 over n plus 1. Okay, which is equal sa 1 over n times n plus 1. Kasi n plus 1 minus n, that is 1 na lang. Okay, so which is approaches to 0 as n approaches infinity. Okay, so yung x sub n minus y sub n is approaches to 0. But, check natin, yung f of x sub n minus f of y sub n. So, saan siya equal? F of f sub n is equal to 1 over x minus 1. Okay, so yung x natin is 1. So, this is 1 plus 1 over n minus 1. Ayan yung una. Minus 1 over, ito naman yung 1 plus 1 over n plus 1 minus 1. Okay, so kung napapansin nyo, ano matitira dyan? 1 over n dito, 1 over n plus 1. In which, mas simplify siya, that is n minus n plus 1, nakagroup. In which this is equal lang sa 1, which is not equal to 0. So therefore, this is approaches to 1. So meaning, yung f of x natin is not uniformly continuous. Kasi nga, closeness is important. Okay, so f is not uniformly continuous on 1, 2 close. Okay, so hindi siya continuous doon. So importante talaga na dapat close ka sa close interval siya para maging continuous. Okay, next is boundedness is necessary. Okay, so for example na lang, bibigyan na ako, hindi ko na solve. Let's say f of x is equal to x squared on interval 1, positive infinity. So, ang makukuha mo dyan is, hanap ka ng dalawang sequence. So, try mo na lang. So, try mo to. So, we have 2 sequences. So, try mo yung sequence na to. We have 1 plus n and 1 plus n plus 1 over n. So, try mo yung dalawang sequence na yan. Observe mo x sub n minus y sub n saka yung f of x sub n minus f of y sub n. Tapos, mapapansin mo hindi siya uniformly continuous. So, importante pa rin si boundedness. So, ibig sabihin dapat walang infinity or negative infinity na nakikita. Okay, so again, remark dito sa ating sa uniform continuity, dapat close siya at the same time bounded. Yun yung, kaya nga ang definition, if D is closed and bounded set, then every continuous function on D is uniformly continuous. So, kaya siya naging property or remark dito. So, again, thank you for watching. Hoping na panoorin mo pa yung mga next video natin.